In this video, we're going to look at a really fascinating subject in maths called sequences. By the end of the video, you'll be able to identify and work out three types of sequences. So there's arithmetic, geometric, and quadratic. We also will take a look at how we can find rules or nth terms. So, for instance, we might be asked to find the 5th term or the 16th term, for instance, by deriving a sequence for each of those. So let's get stuck in. Sequences are ordered lists of numbers or shapes that follow a specific pattern. So the skill we're focusing on is recognizing the types of patterns and understanding how to describe them with a rule that not only can predict the next term, but any term in that sequence. Here are some examples. Let us start with an arithmetic sequence. These are sequences where the differences between consecutive terms is always the same. So it might be increasing by a certain number or it might be decreasing by a certain number, but it's always the same number. And that difference we call the common difference. For example, in the sequence 3, 7, 11, 15, 19, the common difference is 4. So if we want to find the nth term of this arithmetic sequence, we want to derive a formula. So we can use a formula with some key points in our sequence to make this nth term rule, okay? And that is that we take A, which is the first term, in this case 3, and we add it to one less than the term we're looking for. So if we were looking for the 5th term, for instance, we do 5 minus 1. And we then multiply our result by what we call the common difference. So in this case, we said this was 4, for example. So for our sequence, the nth term formula is going to be 3 plus 1 less than the term we're looking for, times by 4, and we can simplify that to become 4n minus 1. So this is the formula that allows you to find any term in a sequence without listing all the terms up until that point. Next, we're going to have a look at a geometric sequence. In a geometric sequence, each term is found by multiplying the previous term by a constant value, okay, which is called the common ratio. So our example 2, 6, 18, 54, you can see that each subsequent number is 3 times the amount of the previous one. So a common ratio is 3. We can find an nth term formula for a geometric sequence. We're going to follow this rule, which is that A, again being your first term, multiplied by your ratio to the power of n, being the number you're looking for, or the sequence number you're looking for, minus 1. So here, the first term would be 2, r is 3, so our formula would be 2 lots of 3 to the power of n minus 1. Finally, let's look at our quadratic sequences. These are sequences where the pattern between the first differences is not constant, but if you find the second difference, you'll find that that is a constant number. So considering the sequence you can see on the screen, you've got 2, 5, 10, 17, 26. Our first differences will show you that we get 3, 5, 7, 9. But as you can imagine, if we find then the second difference in those numbers, we've got a constant number of 2. Now, with quadratic sequences, the formula will have a quadratic in it, so an n squared. Now, the number that goes in front of that will always be half the size of the second difference. So our second difference is 2, so we would have a multiplier or a coefficient of 1. Okay, and of course with algebra we tend not to write the 1 in, but I will in these examples so you can see where it's come from. Now once you have got your base, I suppose, for your nth term rule, then what you want to do is make a matching sequence. Now the way that I find this easiest is to use a skill known as simultaneous equations. So use a couple of your terms, usually your first and second term, and use the sequence that you know so far, so your multiplier of n squared, and then substitute in obviously for term 1 the numbers 1 for n, and for term 2 2 for n, and then what they're equal to in your sequence. And you can then generate sequences or simultaneous equations that you can solve to find out what your b or c values are. And that will generate your nth term rule. So the nth term rule for this one is going to end up as n squared plus 1. As always, just test them out with a couple of your terms and make sure that you can make a matching sequence. So to recap, we have covered arithmetic sequences where we've got the constant value. We've looked at a geometric sequence where we're multiplying by a constant ratio. And then we've just covered quadratic sequences. Remember, first steps, always identify the type of sequence you have and then try and apply the formulas or the skills you need to make it an nth term rule. And that will allow you to generate any term in the sequence you're looking for. Okay, good luck with your pattern work.